A lot of new AI video models are dropping right now. Some look impressive, some don't hold up at all. Today I'm going to show you what actually works and what I would skip. I test these models locally inside real workflows, not demos, not promo clips. If something breaks, drifts, or can't be controlled, you'll see it here. We'll start with LTX-2 because it's been getting a lot of attention. Then we'll move to Wan2.2 and SVI Pro, where things actually start to make sense. This channel isn't about chasing every new release. It's about figuring out what's usable, what's reliable, and what's worth your time. If you care about real workflows and real results, you're in the right place. Let's start with LTX.
This workflow is running LTX-2 locally inside ComfyUI. All model download links are in the notes box. The notes box also shows exactly where each file goes in your ComfyUI models folders. If you want the full working workflows, they are available on Manny's Patreon. Once the models are in place, you can load the workflow and generate immediately.
Guys, the workflow's for free. It's on my Patreon. It's the same workflow as the one on comfy.org. I'll link them both in the description. But before you go running anywhere, let me tell you what's going on with this model. I've been playing with this for a couple of days now, and I've honestly got nothing good to report about it. Before I play these clips, a bit of context on how LTX-2 actually runs locally. This isn't a single model you drop in and go. You're loading multiple large files, including a Gemma text encoder, alongside the video model itself. That's not automatically a bad thing, but it does mean setup is heavier and results are more sensitive to prompts and configuration. The version of LTX-2 that ComfyUI links to isn't just a video model. It's a wrapped version that includes the video model, the VAE, and the audio VAE all bundled into a single file. That's why it can generate video and sound together in one pass. In theory, that's a big plus. In practice, the audio quality is absolutely terrible. So I'm going to mute or lower the sound here because it's not something you'd actually want to use. I want you to focus on the motion and the visuals.
What's up? What are you doing? What's up?
Almost ready for the oven.
What's up? What's up? What's up? It's all in the grain.
Alright, I've shown you enough of this. I'm not keeping this setup on my system, not because it's broken, but because it adds complexity I just don't need. This workflow brings in audio generation by default and that clashes with other things I'm already using. For me, it's not worth the trade-off. So this is getting removed from my drive and I'm moving on. One important thing to say here is that LTX-2 does have a place. If you want to try it quickly, it's available through Comfy's Cloud API. You can experiment without touching your local setup. But for local work, this just doesn't add anything I'm missing. It brings audio generation into the same pipeline, which sounds nice in theory, but in practice, it clashes with tools I already use that work far better. More importantly, it's not building on the ecosystem that most people are already using. Wan2.2 sits on the stack people already know. Familiar text encoders, familiar VAEs, models that are shared across dozens of workflows. That matters because it means stability, compatibility, and community knowledge. When a model becomes widely adopted, everything around it improves. Better workflows, better tooling, better debugging. Wan isn't exciting because it's new, it's exciting because it's embedded. For my setup, keeping things clean matters. I don't want parallel stacks doing similar things in different ways. I want one mature pipeline that I can push hard. That's why this is coming off my drive. So let me show you why Wan2.2 is still the backbone of most serious open source video work. Models come and go, ecosystems are what last.
What makes this different is simple. The motion does not restart. Each segment continues the movement from the last. The character does not reset. The camera does not snap back. Most workflows recreate motion every time. This carries it forward. As long as the shot stays consistent, length framing and resolution, the movement stays natural. That is why this works for longer scenes and why it feels continuous instead of stitched together. Nothing here is hidden, nothing is being faked. This is the model behaving as it was designed to. If you want to try this yourself, the workflow is linked below. There's a free version and a more advanced one for patrons. The notes box has the download links and shows where the model files go, so you do not have to guess. That is all you need.
Before I run this, just to be clear, there are two versions of this workflow. One is a free reference setup that shows how SVI Pro behaves when everything is configured correctly. The one you're seeing on screen adds travel prompts for people who want to push longer shots without rebuilding everything themselves. Same principles, same constraints, just different levels of control. Let's look at the free one first. Alright, now let's slow down for a second and actually look at what's going on here, because this workflow looks intimidating. But the idea behind it is simple. This is a chained SVI Pro workflow. Each block represents one segment of the same shot. The key thing is this: we're not decoding back to pixels between segments. Normally when you generate video in segments, you decode to images every time. That resets the model, you lose motion state, you lose continuity. Here, we stay in latent space. Each segment takes the latent output from the previous one and carries it forward. No VAE decode, no re-anchoring to images, just continuous motion evolving over time. This is why SVI Pro works differently to standard image to video. We're not stitching clips together, you're extending the same motion. As long as you keep the same resolution, aspect ratio and segment length, the model doesn't reset. One important thing to call out here, this workflow uses the SVI Pro version 2 LoRa. This is not the same old SVI Pro LoRa. That one does not preserve motion state properly. These are the version 2 SVI Pro LoRas, high noise and low noise. I'm using the rank 128. They're linked in the notes box and they're essential. If you use the wrong LoRa, the whole thing silently falls apart. The reason this workflow is long isn't because it's messy. It's because we're explicitly controlling what gets reused between segments. The model, the sigmas, the sampler, and most importantly, the motion latents. Everything is deliberate. This doesn't mean every generation is perfect. Long shots are fragile. Prompt wording matters more. Small changes compound over time. But when it works, this is the first time long-range motion continuity actually feels real. Let's run a couple of generations with this setup so you can see how it behaves. One quick thing to clear up before I run this. For these tests, I'm using the FP8 scaled WAN base models. That's a deliberate choice. FP8 gives much faster iterations, which matters when you're testing long shots and multiple segments. There is a small precision trade-off compared to the FP16. If your machine can handle FP16 and you want to maximize fidelity, you can absolutely use it. You can also use a variety of fine-tuned models. Everything here works the same way. Just swap out the base models for whatever your system can run. You'll also see a Lightning LoRa in this workflow. That's optional. Lightning speeds things up. It can be useful for testing and iteration. If you're using a fine-tuned WAN model that already includes Lightning behavior, turn this LoRa off. FP8 or FP16, Lightning on or off, choose what fits your hardware. The motion continuity is what matters. So let me run this workflow. And one thing you'll notice here, there are no previews. This workflow doesn't stop to decode or show intermediate frames. It just runs straight through, segment after segment, all in latent space. Each part hands its result directly to the next one. Nothing gets converted back to images until the very end. Once the last segment finishes, the workflow goes back, collects the full latent stack, and only then decodes the video. That's why it runs fast, and why motion stays continuous. This is Ova, a character from an upcoming series I'm working on. She starts off clearly stylized. Anime proportions, bionic elements. As she begins walking and dancing, you can see the motions holding together really well here. The walk transitions into movement without snapping or resetting. There is some unexpectedly expressive movement in this run, which actually came from a fine-tuned model. That is not something I prompted directly, it's the model leaning into learned motion patterns. What's even more interesting is what happens over time. As the shot continues, the stylized look slowly collapses. By the end, she's no longer anime, she's fully realistic. That's style drift. Over long runs, the model starts prioritizing physical plausibility over style. Unless you actively reinforce the look, the realism tends to win. This isn't a bug, it's a trade-off you have to manage in long SVI shots. So here's the fix. The reason the anime style collapsed is simple. Over long runs, the model drifts towards realism unless you actively push it back. In this run, I reinforced the style by injecting a short instruction at the end of every segment prompt. Just a reminder to keep the anime look. That one small change is enough to stabilize the style across the entire shot. You're not fighting the model, you're nudging it back onto the same visual path each time. That's the difference between hoping a long shot holds and actually controlling it. This doesn't mean every run will be perfect, long shots still need care. But with simple reinforcements like this, SVI Pro becomes usable instead of unpredictable. Now let's look at what happens when you take this a step further. This final workflow builds on the one you've just seen. Same SVI Pro setup, same motion rules, and the same constraints. What changes here is how prompts and outputs are handled. Instead of one static prompt, this workflow uses a line-separated prompt. Each line represents a stage in the shot. As the workflow runs, it loops through those lines one by one. Each segment injects the next line and continues the same motion forward. Nothing resets, motion stays continuous. The other difference is the stage separation. Each segment has its own preview and combine step. You can see the output after the first segment, after each additional segment, and as a continuously growing combine sequence. There's an initial segment combine, then rolling segment combines, and finally a full combined output at the end. You can choose to save these or just use them as a preview. That separation gives you control. You can decide which stages are worth keeping, you can stop early if something drifts, or you can let it run and review the full sequence. Nothing is hidden, you can see exactly how the shot evolves. This still isn't fire and forget. Prompt wording still matters. The order matters, and long shots amplify small mistakes. But with stage separation and prompt travel together, this becomes a practical way to direct long shots, not just hope they work. At this point, you're not generating clips, you're directing a sequence. But before I wrap this up, I want to be clear about the limitations you're seeing here. There is some slight style drift in longer runs. That's expected. You can control that with lowers and consistent style reinforcements in prompts. It's not a deal breaker, it's something you have to manage. You'll also notice some color grading shifts between segments. That's easy to correct. Using a color match node and inputting your reference image as a guidance means this problem is easily solvable. Prompt adherence is the hardest part. Long shots amplify weak prompts. You have to separate intent clearly. Movement, style, progression. There is still some trial and error. That's just the reality of long-form generation. But with those caveats, this is still a valid pipeline. It's controllable, it's repeatable, and it's the best way I've found to do long-range motion in open source video. You're not pressing a button and hoping, you're directing, and that's the difference. But long scene generation isn't always what cinematic work needs. Most great shots are short, deliberate, and cut together. SVI Pro is useful when you genuinely need continuity, but it's not a default. I've also got a high-quality 20-second generation pipeline that runs a dual pass for extra fidelity. That deserves its own video. And there's another angle I want to cover. Use long video output inside a video-to-video infinite talking workflow to create extended animated lip-sync scenes. That's coming too. For now, everything you've seen here, the LTX, the WAN and SVI workflows are linked below. Grab what you need, experiment, and I'll pick this back up in the next one. Thanks for watching, and I'll see you next time.
The city sells perfection. But perfection is expensive. Someone always pays for it, usually in pieces. Up there, everything is smooth, optimized. Down here, things still touch back. They think the outside is chaos. It is not. Chaos is honest. When something old wakes up, the system pretends not to hear it. I hear everything. If this world is going to break again, it will not be quiet.